Hi, this is Grover with Blue Collar Codes. This episode's going to be a summary of episodes 11 to 13. If you wish to follow along, you can find a link to the file summary underscore 11 to 13.py in the GitHub repository, linked in the video summary. So we're going to go over the LEGB rule and scope, class creation, and then a bit into class inheritance. So LEGB rule stands for local, enclosing, global, and built-in. And there is such thing as called a name resolution, which is basically when you're using a variable name or even a function name, it needs to search the scopes for those names, and based on where the code originated or where the lookup is originating, which scope, it will depend on where the name is actually found. So all of these scopes basically, to oversimplify most likely, but it's just basically a table that has a variable name like A or B, and then the values or the locations of the values in memory, and then it where it belongs, where that table belongs, and it's either local, enclosing, global, and built-in. And the order in which this name resolution takes place, the process, is local, enclosing, global, then built-in. So it'll always start with the local scope and enclosing scope. If it can't find it in local scope, global scope, if it can't find it in either of those two, and then so on. And if it can't find it at all, then you have a name error thrown. So local scopes are created when you're using certain keywords. For instance, here, def, function name followed by a colon. This requires indentation after the initial line. And all of this code here is considered the local scope of using local A. And as you can see here, VS Code, as I'm sure other IDEs kind of highlight or showcase for you, which code belongs in which function's scope. And there are other keywords such as class, try, except, finally, if else, and so on. A lot of these keywords require a colon at the end and then indentation, and then you know that the scope is local to that area or to whichever block is belonging, is in the header block, so to speak. It'll make a little bit more sense as we go through it. So here you also have global scope, which is basically just the top level scope of the file. So anything that is not indented, such as this A and this B, these are considered global variables, and so they would exist in the global scope namespace. And to get an idea of how this order works, let's just go through these examples. First, I'm going to hit save and then press play just so we can verify here with these prints that the actual variable being pulled here and printed has the value that we expect. So here, this function using local A, you're actually reassigning or creating the variable A in this local namespace and assigning the value 5. When you print it, it will find that A, that name, here in this local namespace, and what prints is 5 as expected. And then here you have a function that does not define A, and therefore it'll search first the local scope of using global A. It won't find it, so then it'll search to the enclosing, but there isn't any enclosing, right? Enclosing basically just means nesting, when things are nested, and I'll showcase that in the wrapper function here. So what it ends up pulling here, because there isn't a local A and there isn't an enclosing A, it'll take and search the A in the global scope. And so it'll take this A and it should print 10. And here, as you see, it prints 10 over here. Now, if you wish to gain write access to a global variable, you can use the keyword global. And so by declaring global and then the variable name, I've reassigned and altered the global variable from 10 to 15. And now when I print, it'll find this in the local scope because you pulled it in. And so when it prints, it'll print the 15. And then I placed another print in here just so you know that it's pulling from the top level, not from within a function. And they're both coming to 15. So now the wrapper class, as promised, I will go over in closing scopes. And basically, when you have nested scopes being created, in this case you have an outer wrapper function that has an inner function created as well. So the wrapper function's local scope is all of this, and then the inner function's local scope is this. So I have a series of prints here to show you how you can use non-local, similar to how you use global, to gain access to the enclosing scope's variable name A. And then you can alter it here. So it's going to take the 30, it's going to print it here, it's going to alter it because we took write access, or we allowed write access by using this non-local keyword and then declaring the variable A. And then now we're making an assignment, so we're changing this A to 25, we're printing it, and then I showcase again or show you again that I am printing the A external from this scope just to be sure that it altered it. And so as you can see here, it has 30 for the wrapper function, 25 for the inner function because it was altered, and then now back in the wrapper function, when it closes it out, it's printing a 25 as well. So again, LEGB rule, local scopes are created when you're using certain keywords that require a colon at the end of the line. All the indented code belongs to the local scope of that variable name you declare using that keyword or that scope. And if it can't find the variable name of the local scope, it'll go with the enclosing, and then it'll go with the global, then it'll go with the built-in. If it can't find it anywhere there, then it'll throw an error. So that was scope, an overview. We're going to switch over to class creation. So the syntax is using the class keyword space, camel case, name of your class, and then colon if you do not want any inherited classes. If you don't want it to be a subclass, you want it to be its own base class, then that is the format that you would use. So now the code underneath, I'm just going to go over basic terminology. If you declare a variable or assign a variable at the top level, it's considered a class variable and it will live only on the class. Meaning when you create an instance of it, it's not going to live on the instance, it is going to live on the class. This line of code here, the def space 2 underscores init 2 underscores and then parentheses here, is called a constructor, and it basically allows you to input attribute values upon creation of the class. So here you have one other thing of note is you have to use the self keyword. That's the way for this class to keep track of its instance, of which instance it actually is. It's just a necessary part of creating classes. And then here you have a value that ends up being assigned to self.value, which is the attribute of a myClass instance. So I have this showcased here. So you have myClass, I instantiate it with a 10 integer, and then I can display that, and it will go ahead and it'll display that. And that's actually what I have all the way up here, since that's the first executable code. myClass value 10. So now if you wish to go into and create more complex class structures and utilize inheritance, inheritance basically means that you can create a base class that has a lot of the necessary or nuts and bolts attributes as well as methods that you wish to make available to all of your subclasses. It should limit the amount of code you need to rewrite in the subclasses here, unless it's basically, its best use case is when you have situations where that actually is beneficial. When you have a template where then you can subclass a little bit because you need to have different versions of this template that have slight differences, and you want to differentiate them for use in different situations. So that's where it makes most sense. if you have to create a class structure where you're literally rewriting the class content for each subclass, then inheritance is almost meaningless in that sense, in that case. So what I'm going to go into here, without trying to dive too deep, is just to go over these outputs and why they take place. Note here that I made a base class that has some of the same core methods and attributes, and then I subclassed that base class by putting it in parentheses, and I made two different subclasses just to then show you something called method resolution order as well as attribute resolution order, meaning the inheritance priority that you give it. Basically, the first one is going to be searched first for any method that doesn't exist on the current class. It'll search up the tree and it'll go to subclass first for child 1 and then subclass 2. For child 2, it'll go to subclass 2 first and then subclass 1. So going down here, without diving too much more into the organization of how I made this class tree, because I really just want to impress upon you the importance of choosing the priority here and what inheritance actually means as far as method resolution, meaning where does it find the method and where does it run the method. And so here I created C1 as child 1. It has a 10 and a 20 as their variables. And here I am printing or doing display base. And as we can see on child 1, there is no display base defined separately. So what it's going to do, in order to print this line of code here, base class value 10, it first searches the child 1 class. It doesn't find it, so then it'll go up to the first subclass in this list because you gave it priority. So it'll look for subclass 1. It doesn't see display base, so then it'll travel up to base class, and then it'll find display base, the top level superclass, and then it'll print this line of code. So why is this unique? It's because it was still able to run without being on the lowest child class that we created, the instance. It searched all the way up the tree to then run that line of code from this base class. That's just something that you need to keep aware of. And it can get pretty convoluted if you start having, say, diamond patterns and multiple grandparents and what have you that all have same name, methods, and attributes. So here, just to go over the point one more time, so that display base searched all the way up to the grandparent class, but then display exists on the two subclasses. And because the two children are different, they're going to find this display class on a different subclass. So you have C1 has subclass 1 as its first parent, and so what it's going to do is it sees that there's no display class, display function method on child 1. It's going to search up the tree to subclass 1 and it'll find the method display here and it'll print that value. And so again, this is blue collar codes, the quick and dirty. We were just going over scope, basic class creation and terminology, and then an exceedingly brief overview of inheritance and just what happens when you're trying to make a method call if the method doesn't exist on your child class. Thank you for joining. See you next time.